We all know exactly what it feels like when an interface fights back. You're trying to complete a simple task on a screen, and suddenly you hit a wall. It is an invisible friction that causes physical frustration. Measuring that friction accurately is notoriously difficult. Aggregate click tracking shows us where a user clicked or where they stopped. It never tells us why. And post-action surveys rely entirely on what a person remembers feeling after the fact, which is often biased and rationalized. Many current tools attempt to solve this by running screenshots through cloud-based AI. But because these models are disconnected from the actual site architecture, they often report issues that aren't there, presenting a guess as a definitive number. Look at this standard system flow. These tools export sensitive human faces over the network, process them remotely, and compress complex human struggle into a single erratic optimization score. They prioritize a convenient summary over the privacy of the person at the screen. Relying on systems that cannot prove their findings or respect data privacy leaves builders blind. Measuring actual human interaction requires a completely different, honest approach. AffectEQ is built to do exactly that. We call this new category experience evidence. The goal is to measure the probable human experience at the screen, relying on 3 strictly independent kinds of evidence. As you see in this scan, the first witness is a deterministic UX audit. This is a strict, rule-based framework running entirely locally. There is no AI involved here. It checks the page against 110 expert usability rules, grading the interface the same way every single time. The second witness is an AI visual review. Operating in parallel with the rulebook, a local vision language model looks directly at the interface. It observes and critiques the layout the way a sharp human designer would. But an AI alone is prone to error, so AffectEQ runs a strict verify pass. If the vision model cannot definitively ground its critique directly in the page architecture, the system throws that finding out. On complex sites, it routinely drops over 60% of the AI's raw observations. An automated audit is only trustworthy if it is structurally forced to reject data it cannot prove. A cold code audit is still missing the most important variable, the physical behavior of a real person navigating the interface. The third witness is the live human signal. AffectEQ watches the user's face on device, tracking 478 distinct facial landmarks to capture their physical affect. We must be extremely clear here. This physical signal is validity-gated corroboration. It is never ground truth. The system does not read minds, and it does not report human emotion as an absolute fact. This dual-axis timeline maps cognitive load. By fusing behavioral struggle, like erratic mouse movements, with facial effort, the system identifies the exact moments where the interface forces a user to work too hard. To accurately map the probable human experience, the deterministic rules and the AI review must be anchored by the physical reality of a real person's reaction. Having 3 kinds of evidence only matters if you maintain their independence. Notice how these streams flow. AffectEQ refuses to blend these signals. The data streams from the deterministic audit, the AI visual review, and the human module are kept in 3 strictly separate lanes. There is no composite score, on purpose. Instead, we look for convergence. A finding is only escalated to a top priority when the automated rulebook and the live physical human reaction intersect directly on the exact same screen element. If the code says a button is broken and the human's behavior proves they are struggling to click it, that is converging evidence. And if any individual signal becomes unreliable during a session, say poor lighting compromises the facial tracking, the product's own validity gate excludes that data entirely and honestly discloses the gap in the final report. Analytical rigor requires calibrated confidence, where every claim has independent, unblended proof. Capturing this depth of true human evidence brings an immediate architectural requirement: absolute security. The entire suite operates on a local-first invariant. The deterministic rules, the AI models, and the live human tracking all run 100% locally on a single machine you control. Zero data, no faces, no screen recordings, no code ever leaves the box. This local-first architecture functions as a passport. It makes it possible to audit the human experience in strictly regulated spaces, like healthcare, finance, and government, where cloud-based tools are contractually and legally disqualified. You get a ranked verdict with the receipts. Every finding traces back to the independent witness that raised it, allowing development teams to stop guessing and start proving it. Demand real experience evidence. Measure the probable human experience of your software with independent, honest tools.